Hey 8th graders, happy STEAM Wednesday. So today in class you guys are going to be doing an activity that looks very similar to one of the labs you guys are also doing. So this is kind of your warm-up lab to test out at home and to see what's happening on a molecular level before we do it in class. Alright, so this is the pHet thermal energy, and your learning targets are I can describe the kinetic energy of molecules in a system of varying temperatures, and I can model how energy is transferred between two objects. So to kind of start you guys off today, you guys will have your questions that you kind of need to answer prior to starting this. So you guys will just use your draw tool for this and circle what you think is the correct answer. So if a sample of water has a high temperature, its molecules are moving either faster, slower, or about the same. If a sample of water has a low temperature, its molecules are moving faster, slower, or about the same. So if you guys were comparing the opposite. If a sample of water has high temperature, its molecules have a blank kinetic energy. So again, circle high, average, or low. And if a sample of water has a low temperature, its molecules have a blank kinetic energy. So if it's low, how is it different? Okay, again, as always, when you're using the draw tool, make sure you guys click back on the cursor. All right, so let's get into the simulation. Right here is your link for the simulation. If you right-click it and hit Open Link, it should pop up for you in pHet. Your guys' directions are as follows. First, in the upper right-hand corner, select the energy symbol. So open the pHet link, choose Intro. And then in the upper right-hand corner, select energy symbols and link heaters option. So what the link heaters option does is it allows you to heat both heaters at the same time. So if I heat one, the other one heats the same amount as well. Okay, so I'm going to go to Intro. I am going to go to energy symbols and link heaters. And then there are 4 thermometers. Add a thermometer to each of the 4 items available: iron, brick, water, and olive oil. So that the thermometer's in the bottom right-hand corner of each object and not covering up the object. So you guys need to kind of see what's going on in the object, so make sure it's off to the right-hand side. And then as long as the little triangle changes to the color of the object, you are detecting its kinetic energy. So if I drag a thermometer here to my iron block, I want it off to the right-hand side. Notice how the little triangle turns gray like the color of iron. It's also off to the right-hand side. It's now attached to that. So I can still see what's happening in the block of iron without covering it up. Okay? And I know it's obviously catching the temperature because it turned gray. Here's one for my brick. Here is one for my water. Notice how it turned blue. And here's one for my olive oil. Notice how it turned yellow. Okay? Alright, so now moving on, you're going to make some predictions. What do the E's inside of each object represent? So if you guys aren't quite sure, go back, kind of play around with that simulation. You guys will find the answer in there. If you add heat, again, don't do it. This is just a prediction. What will happen to the E's inside of each item? And if you add ice, don't do it yet. Predict what will happen to the E's inside of each item. So make predictions there, and then you're going to go ahead and make a couple more predictions. Which has a higher energy, water or olive oil? This is really more of an observation than a prediction. So which has a higher energy, water or olive oil? Answer, and how do you know? And which has a lower energy, brick or iron? Okay. All right, moving on to the next part. Add the beaker with the water to the left burner and the olive oil to the right. Now test your predictions. So here's your water here. Here's your olive oil here. And then you guys can go ahead and test your predictions. So your predictions here said, if you add heat, predict what will happen to the E's inside of each item. So do that. You'll link them. You'll add heat. So because they are linked, if I turn this one up, this heater will also turn up. So if we turn the heat up on this and raise the temperature, what's going to happen to the energy? And same if we lower it. So if I drag this down, I should see both of them are cooling off. Okay, so test your predictions. What happened to each the water and olive oil when you added the heat? What happened to each the water and the olive oil when you added ice? Which was a better conductor of heat, water or olive oil? How do you know? Okay, so think about what we kind of learned when we did the thermal energy demos. That'll help you guys with this question. Okay, moving on to the next part. Remove the water and olive oil and then add an iron block to the left and a brick to the right. So these two are off. Iron to the left, brick to the right, and go ahead and test these. What happened to each the iron and the brick when you added heat? What happened to each the iron and the brick when you added ice? And which was a better conductor of heat, the iron or the brick? So answer, and how do you know? Okay, last little part of the sim. So finally remove the iron, but keep the brick on the burner. So brick's on. We're going to put water up there instead. Replace the iron with the beaker of water. Unlink the heaters by clicking link heater. So basically, we're going to unclick this here. That's going to allow us to change the water in one way and the brick in another. Okay, start by heating up the brick to its full temperature, so you're going to get it as hot as you can, and then cool the water down to its lowest temperature. So you're going to have a hot brick and cool water. Add the brick to the beaker of water and observe what happens. Okay, then what you guys are going to do after you observe what happens is you guys have 3 models you're going to fill out. Okay, so in the 3 models, you guys are going to use the draw tool to do this. You're going to add some ease to each sample. And remember, you kind of want to add as many E's as you think is appropriate. So if you guys have a piece of matter with a lot of energy in it, you're going to add a lot of E's. Okay, so make sure you guys kind of represent how much energy that object has by adding either more or less E's. Okay, and then you're also going to fill in the blank thermometer. So there's 3 models you're going to do. This one is going to represent before you add them. So you're going to heat the brick up and you're going to cool the water down. So I want you guys to use the draw tool to add E's, so you guys can just write E's in and on the samples themselves. I'm going to go ahead and erase those. You guys can use different colors if you'd like. And then I'm also going to fill in the thermometers to kind of represent what each look like before I did anything with them. So you guys can kind of just draw a line to represent what they look like. Again, I'm just drawing stuff. I'm not necessarily putting thought into it. Okay, and then you guys are going to move on. This next model that you guys are going to do are going to represent what happens immediately after the brick is added. So if we were to take that brick and drop it into the water, immediately what happens? What does our temperature look like? What does our water look like? You guys can pause your simulation to kind of model what this looks like based on what you see in the sim. So you guys can hit pause. And then about 30 seconds after, what does it look like? Okay, so our brick has been in our water for about 30 seconds. So what does the temperature look like? What do those E's look like? Okay, so don't forget the E's on both the water and the brick here. They shouldn't necessarily look the same. Okay, finally, do your wrap up. Do you have any questions? Yes or no? If you have any questions, type them below. And then 4, 3, 2, 1, how do you feel you did on this assignment? Okay, and finally you are done. Go ahead and hand this in. And again, if you guys have any questions that are preventing you from doing this assignment, please let me know and I can help you out. Have a wonderful day.